All right, so far we've talked about confidence intervals for averages. In this lecture, we're going to be talking about how to create a confidence interval for proportions. So let's get started. Now I want to remind you what a confidence interval is. A confidence interval is an interval or a range that tries to capture the true parameter, like an average. But a confidence interval might also try to capture a different type of parameter, like a proportion. Now, what are proportions? Proportions are values between 0 and 1. And if you like to think of it as percentages, you can think of it from 0% to 100%. Now, these numbers represent what portion of the whole you're referring to. So 0.5 or 50% or 1/2 would correspond to half of your group. Now, when we were talking about averages, averages do not have many restrictions. For example, in the context of age is not really restricted. We can talk about an age of 0, we can talk about an age of 1,000. There are not many restrictions to average age. But with proportions, well, they are restricted. In every circumstance, proportions are values between 0 and 1. And that can make the math a little bit tricky. So let's go through this math together. We're going to head over to the computer. So I'll see you there. All right, so I'm going to show you guys the formula for confidence intervals that are meant for proportions. Now, proportions and averages are a little bit different. Proportions, which are typically denoted as p hat, are not the same thing as like averages. They work a little bit differently. So averages are meant for random variables like height, SAT scores, IQ scores, shoe size. These things are random variables. Proportions, though, are numbers that vary from 0 to 1. There are boundaries for proportions. So things kind of change when we talk about standard deviation because proportions are kind of already limited in how spread out they can be because they are bounded. So we can't have a standard deviation that's really, really large because, again, proportions are always going to be bounded between 0 and 1. So because of that, the confidence intervals for proportions work a little bit differently. So the idea is you're trying to capture proportion. So you have, like, let's say a sample proportion, and you plus or minus z star, which is that 1.96 that we've been talking about so far for 95% confidence intervals. And our denominator is still going to be the square root of n because we're taking the population standard deviation and we're dividing by the square root of n to get the sample standard deviation. Now, here's where things get a little bit different. The standard deviation is not just going to be, take all the numbers, find the average, find the distance from the average, square all those numbers, add up all those numbers and divide it by n minus 1, and then take the square root. That's how you would typically calculate the standard deviation. That's not how we're going to calculate the standard deviation here. The standard deviation for this is going to be the square root of p hat times 1 minus p hat. And again, the reason why the standard deviation is different here is because p hat is bounded between 0 and 1. There are boundaries to p hat. Whereas averages like height, you can be as tall as you want. Age, you can be as old as you want. Income, you can be as rich as you want. Whatever random variable you give me, there are not really any sensible boundaries that you can place and say you cannot go outside of these boundaries. And if there are, then we'd have to kind of change how we calculate standard deviation a little bit. So this is how you calculate standard deviation for proportions. So let's go over an example. So this is kind of how you would word a question in this sort of study. What proportion of the sample is, and then you fill in the blank here with whatever question, Republican, blonde haired, I would say. And And so you fill in the blank here, and then you use that information and the sample size to calculate your confidence interval. So let me give you guys an example here. We're going to say we sample 100 people. And our proportion, well, first let's talk about what question we're asking. We're figuring out how much percent of the population is self-proclaimed Christian. In this example, the proportion we get is, let's say, 0.74. So 74% of our Americans that we sampled were self-proclaimed Christian. So that being said, let's figure out the confidence interval. This is all the information you need. You don't need to calculate standard deviation or anything like that, because you can't calculate standard deviation when you have Christians and those that would not identify as Christians. So you have those two groups. There's no way you can measure spread between those. The only way you measure that is by taking the square root of p hat times 1 minus p hat. We'll do that in a second here. So here's our confidence interval. We're going to be taking 0.74. And we're doing plus or minus. Now our denominator is still this, we have to do z star, which is 1.96. We're going to be doing a 95% confidence interval. And I just want to get used to doing 95% confidence intervals because those are so useful in science. That's what scientists use almost every single time, with the exception of physics. Physics, they go pretty intense. They go like 99.99. They're ridiculous. Anyways, our denominator is still the square root of 100 here. But our numerator is going to be a little bit different here. Our numerator is going to be 0.74, which is our p hat, times 1 minus 0.74. And now we're going to figure out what these numbers are. So I'm going to first figure out what our margin of error is. Again, this portion right here is the margin of error. It's what I'm adding and subtracting from the average that I calculated. And so this is 0.74 plus or minus, let's see that here, 1.96 times the square root of 0.74 times 1 minus 0.74 divided by the square root of 10, square root of 100, which is 10. And I get 0.086. All right, so now our confidence interval, we're going to do 0.74 minus 0.086 to get 0.654. And then my second number would be, looks like see if I can do this in my head, 826. Now let's talk about what this means. So if I came out with this confidence interval, what I'm saying is that I'm 95% confident that the proportion of self-proclaimed Christians in the U.S. is somewhere between 65.4% of the population. So that's the lower estimate, and the upper estimate is 82.6% of the population, which would mean that it's unlikely that 50% of the population is Christian. It's unlikely that 90% of the population is Christian. It could be that the population of the proportion of the U.S. that is Christian, that self-proclaimed Christian, is 74%. But I'm not making that claim. I'm not making this claim. I'm actually making this claim. And that's what you should do whenever you conduct an experiment, is that confidence interval is the claim that you want to make. That confidence interval is the claim that you want to make. So that being said, we kind of narrowed down what proportion of the population is Christian based off of this test. Now later on we're going to be talking about z-tests and t-tests with these things, in which case really the only thing that will change is this 1.96, and we'll be determining whether or not things are within this confidence interval or not. I'll see you guys then. You just watched a video from Amore Learning. We provide free math videos and we offer many online courses. We also provide free math tutoring via YouTube Live every Thursday and Sunday at 9 p.m. Eastern Time. Make sure to subscribe to our YouTube channel and like this video to get access to all of our free content. And put a comment in the comment section if you have any math questions. Check out all of our courses on amorelearning.org.